Hello students, welcome to the PECO Virtual School. This is Mathematics by Mr. Twinomugisha, Lambert. We are going to look at percentages. So basically when you talk about a percentage, is a fraction whose denominator is 100. Fortunately in mathematics we don't ask for definitions, but they help us to understand the concepts more. So a percentage is that fraction whose denominator is 100. For instance, if I say 48 out of 100, that one automatically means 48%. So the symbol for percent is provided there. And our other note here, to change a percentage into a fraction or a decimal, simply divide by 100. We have a simple example that 75% is simply by definition 75 out of 100, because percent means out of 100. Now when you simplify this, you end up with 3 out of 4, which is 0.75. So when you reduce this by 5 by 5 or by 25 by 25, whichever way you find convenient to reduce. So to change a fraction or a decimal into a percentage, we simply multiply by 100. A simple example, 3 out of 4 as a percentage is 3 out of 4 times 100, which gives us 75%. But earlier on we said that 3 out of 4 is the same as 0.75. So 0.75 times 100 gives us 75%. An example there, example 1. Express each percentage as a fraction in the simplest form. Remember we said that a percentage is a fraction whose denominator is 100. So 20% is the same as 20 out of 100. Then you simplify, you can reduce, and then you come up with 1 out of 5. The same thing, 25%, that will be 25 out of 100. You can reduce, and that will be 1 out of 4. You guys have better ways of simplifying this. Some can reduce by 2, and so on, until you reach a point where the fraction cannot be reduced. Now 24%, that is 24 out of 100, which we can reduce to 6 out of 25. 12.5%, same working, out of 100, and we reduce to come to 1 out of 8. The next question, express each percentage as a decimal. So part A, I have 20% as a decimal. So percent means out of 100. So once I divide this into decimal, you can even use your calculator. 20 out of 100, that will give us 0.2. The same principle applies 25%, which is 25 out of 100. Can divide this with a calculator to give us 0.25. The same concept, 45 out of 100 divide will give us 0.45. 48.5%, that is 48 out of 100, which gives us 0.485. Now check our example 3. Express each fraction as a percentage. The first fraction is 3 out of 4 as a percentage. So if you have a fraction and you want to express it as a percentage, you simply multiply by 100. If you have a decimal and you want to express it as a percentage, simply multiply by 100. So I'll take 3 out of 4 times 100%. That will give us 75. Just check this. 3 times 100, that gives us 300. Divide by 4 to give us 75%. The same concept, 1 out of 5 as a percent times 100. So this is 100 divided by 5, which gives us 20%. 1 out of 3 times 100, that will give us 33.33% recurring. 3 out of 5 times 100 will give us the 60%. Now how about 2 out of 3? Use the same principle. 2 out of 3 times 100. This is 200 divided by 3, which gives us 66.7. Next example, express each decimal as a percentage. I told you that once you have a decimal or a fraction, simply multiply by 100. So I'll get 0.2 and multiply by 100%. That will take us to 20%. 0.25 times 100 will take us 25%. 0.45 times 100 will give us 45%. 0.125 times 100 will give us 12.5. 0.4825 times 100 will give us 48.25. Now, example 5. Find 35% of 80. Remember, percent means out of 100. So, 35 out of 100 times 80. 35%. Percent means out of 100 times 80 will give us 28%. Find 25% of 120. So 25%, 25 out of 100 times 120. So we can multiply this 25 times 120. Whatever you get, divide by 100 to give us 30. Number 6 there, our example. Express 20 as a percentage of 80. So we shall take 20 out of 80 times 100, and that is 25%. So 20 as a percentage of 80 is simply 25%. So we have a word problem there. In a bag of 120 eggs, 30 are rotten. Find the percentage of rotten eggs. So a bag has 120 and 30 are rotten. So the percentage of rotten eggs, we shall get the number of rotten eggs out of the total number in the bag, then times 100. And the computation will give us 25%. Check this word problem in a test marked out of 60. Maybe a student has scored 40 out of 60, 20 out of 60, say 17 out of 60. So we have that in a test marked out of 60. A student obtained 48 marks. Find his percentage mark. So a student scored 48 out of 60. So in other words, express 48 as a percentage of 60. So 48 out of 60 times 100. And that will give us 80%. So question 9, in a class, 90 students are boys. And in a class, 90 students are boys and 25% are girls. We need to analyze that. In a class, 90 students are boys. So we don't know the total number in class, but we know the number of boys. So it is a class and 90 are boys. 25% are girls. The question is, find the number of girls in the class. Now we need to think. It is a class, 90 students are boys, 25% are girls. The first question you need to ask yourself, if 25% are girls, what is the percentage of boys in the class? That is the starting point. 25% are girls. This is the most important part. 25% are girls. So if 25% are girls, then the percentage of boys will be 100 minus 25, which gives us 75%. But now this 75% is equivalent to the 90 students. So what do? 75% will represent 90 students. Now how about 1%? To represent 90 out of 75 students. But I want the number of girls. And the number of girls are represented by 25%. So if 1% represents this, then 25% will represent 25 times 90 out of 75. 1% is this. 25% will be 90 out of 75 times 25. It's like saying one class has 40 students. How about 3 classes? 1% is equivalent to 90 out of 75. How about 25%? So we just multiply 90 out of 75 times 25, and that will give us 30 students who are girls. So if 30 students are girls and 90 are boys, then it means that the total number of students in the class is 120, much as that was not asked. If 90 are boys and 30 are girls, the total number in class will be 30 plus 90, which gives us 120. But that was by the way. Now, let us analyze this question. A school has a population of 4,000 students. 60% are boys. So ask yourself, what is the percentage of girls? If 60% are boys, what is the percentage of girls? As you read through the question, you try to analyze. A school has a population of 4,000 students. 60% are boys. Ask yourself, what is the percentage of girls? As you continue. So the percentage of girls will be 100 minus 60, which is 40%. Just part of the analysis. So 80% of the boys and 25% of the girls are day scholars. 25% of the girls are day scholars. So ask yourself, what is the percentage of girls that are in boarding? So if 25% are in day, then 75, 100 minus 25 gives us 75% are in boarding. If 80% of the boys are in day, then 100 minus 80, which gives us 20% of the boys are in boarding. Find the male students in the school. So the male students, we want the number of boys. And the question is clear. 60% are boys. So 60 out of 100 times the 4,000. And once you reduce this, you come up with 2,400 students. So if I have 2,400 students as boys or as males, then the number of females in the school will be the total, which is 4,000 minus the number of boys. And that gives us 1,600 students. Female boarding students in the school. We go back. The females are 1,600. But 25% are day scholars. So what is the percentage of boarders? That will be 75. Because 100 minus 25 gives us 75 out of 100 times the 1,600 female students. And that gives us 1,200 students. Now, males in day. We said that the percentage of boys who are in day was 80 out of 1 times the number of boys. And that gives us 1,920 students. How about females in day? Females in day, I'll get the total number of females, which is 1,600, minus the females who are in boarding. And we shall end up with 400 students. Now, number of boarders in the school. If I want to get the number of boarders in the school, it means I need to get the boys who are in boarding, boys in boarding plus girls in boarding. So how do I get boys in boarding? I have the total number of boys, which is 2,400, minus the boys in day, which is this. Then plus the girls who are in boarding. And the girls who are in boarding, we had earlier got it as 1,200. And when you add, you end up with 1,680 students who are in the boarding section. So we now need to extend our idea of discussion into what we call percentage change. Percentage change. By how much has a value changed? We can look at some key points. 1, percentage change would be change in value over the original value times 100. Change in value, we shall take the new value minus the old value. Now this magnitude means that you neglect the negative. In case the new value is small and you subtract to get a negative, then we shall neglect the negative. So percentage increase will be increase in value out of the original value times 100. An increase of 20% means that the new value is now at 120% of the old value. percentage decrease, we shall take the decrease over the original value times 100. A decrease of 20% means the new value is now at 80. How do we get 80? Because we are decreasing. So you get 100 minus 20. That gives us 80% of the old value. So percentage error will be error over exact value times 100. Error in value will be exact value minus the inexact value. Now, having talked about that, can we take some examples? The price of an item increased from 5,000 to 6,000. Find the percentage increase in the price of the item. So initially the price was 5,000. It is now 6,000. Can we now take the percentage increase would be the increase out of the original value times 100. So in this case, our percentage increase, we shall now take the 6,000 minus 5,000 out of the original value, which was 5,000 times 100, and that will give us 20%. Now, the next question, the price of an item reduced from 8,000 to 6,000. And the question is, find the percentage decrease in the price of the item. So, we shall say percentage decrease would be the decrease out of the original value times 100. So what is the decrease? It has decreased from 8,000 to 6,000. So the decrease, we shall take the difference. So that will be 8,000 out of 8,000 minus 6,000 out of the original value, which is 80. The price of an item reduced from 8,000 to 6,000. So the percentage decrease in the price of item will be the decrease, which is 8,000 minus 6,000 out of the original. Now the original value here is 8,000 out of 80,000. So you check this. This will be out of 80,000. And once you take the computation, that is 2,000 out of 8,000 times 100%. So 2,000 out of 8,000, that is a quarter times 100, and that will give us 25%. So this is 2,000 out of 80,000. Because the original value is not 6,000, it is 80,000. So this value here is 8,000. And once you take 2,000 out of 8,000, it will give us 25%. So, question 3, the depth of a river was measured as 1.8 meters instead of 1.6 meters. Find the percentage error in the measurement. So, instead of measuring it as 1.6, they measured it as 1.8. So what do? Percentage error, shall take the error over the exact value times 100%. So what is the error? We shall take the difference of 1.8 and 1.6 out of the exact value. The exact value is 1.6. So times 100, and that will give us 12.5%. Another question there. Find the percentage error made in evaluating the square root of xy minus 14 instead of evaluating the square root of xy plus 14 when x is 5 and y is 10. So this is the exact value, but instead of evaluating this, instead we evaluated this. So our exact value is this one, we substitute, and the square root, if we take a positive value, this is the square root of 64, which is 8. Now the wrong or inexact value is this. You substitute the square root of this is 50 minus 14, which is 36. So the square root of 36 is 6. So percentage error is error, which is the difference between this over the exact value, and the exact value is 8 times 100 to give us 25%. So we have some more examples there. Increase 500 by 20%. What did we talk about the increase? That if I increase by 20%, then it means that I'm working at 100 plus 20, which is 120. So we shall take 120, 100 plus 20 because of the increase out of 100 times 500. That will give us 600. So Decrease 400 by 10. Decrease, we are reducing from 100. So 100 minus 10, that gives us 90 out of 100 times 400. That gives us 360. We have a word problem there. An item costing 2,400 is increased by 25%. Find its new cost price. So an increase shall increase 100 plus 25, giving us 120 out of 100 times the 2,400, and we end up with 3,000. Another example there, the same concept. An item costing 4,000 is reduced by 20%. Find the new cost price. You're reducing, so we shall get 100 minus 20. That gives us 80 out of 100 times 4,000. That is 3,200. Another question, question 8. The cost of an item is 4,600 after increasing it by 15%. So when I increase by 15%, I come to 4,600. Find its original cost price. So at 115 of the cost price, we get 4,600. So when you cross multiply here and compute, multiply by 100, multiply by 100. By cross multiplying, multiply by 100, multiply by 100, and then divide by 115. And we shall end up with the cost price as 4,000. Question 9. A trader sells 30 pens at 75,000. If the cost of a pen is increased by 20%, find how many pens can be bought with the same amount of money after the increase. So we need to find out what was the original cost of a pen. Originally, 30 pens were costing 75,000. So the original cost of a pen, of a single pen, would be the original cost of a pen, because we are having 30 pens being sold at 75,000. So we shall get 75,000, check this value, 75,000 divided by 30, and that will give us 250. So you check this. This is 75,000, which is this 75,000, and we divide it by 30, not by 100, but by 30. Now once you divide it by 30, you'll end up with 250. So the new price will now be equal to, because we are increasing by 120, so 120 divided by 100 times 250. So the new price is now at 300. So how many pens can we buy with the same amount of money? We shall get the same amount of money, and then we divide by the number. We divide by the number. We get number of pens will be equal to the amount of money that we had divided by the cost. So the cost here, once we divide this, we shall end up with the number of pens as 25. So when there is an increase, we add on 100, and when there is a decrease, we subtract from 100. Now question 10 there. The length and width of a rectangle were increased and reduced by 20 and 5% respectively. Find the percentage change in the area of the rectangle. So our original area would be length times width. Now new area, remember the length was increased by 20%. So that will be 120 out of 100 times L. Now the width was reduced by 5%. So we are working at 95 out of 100. So once we multiply this, we shall end up with 1.14 LW. So once we multiply this, we shall end up with 1.14 LW. Now the percentage change, we shall take change over original times 100. So our increase, we shall take 1.14 LW, which is this minus the LW. Divide by the original, which is LW, times 100. And we shall end up with, because this LW, 1.14 minus 1 gives us 0.14 LW. So the LW and the LW will cancel. So you have 0.14 times 100, which gives us 14. So that marks the end of our presentation as far as percentages are concerned. Feel free to get in touch with us so that you can ably get the exercise and we evaluate how much of this topic you have mastered. Thanks for listening. Peko Virtual School. No.